Welcome to a lesson with Dr. Powell. Let's take a look at an example of a function and a left inverse of it. Suppose we have f from R2 to R3, and it's defined by xy being sent to xyx, or something like that. Well, what if we go backwards? So inverse for this, a left or right inverse is always a map that goes backwards, from R3 to R2, so it's going back the other way. So what if we go ahead and define this simply as exactly what I've just written? In other words, x, y, x, let's just take it back. This is drop that coordinate and just take it to x, y itself. So it just kind of goes back there. Notice that this, so right at this position, right, if we run xy, if we send it here and we run it back, we're always going to get back to the same place, right? So in other words, the map formally would be like, if I have any xyz in the codomain, let's just drop the z coordinate and just send it to xy. So that's exactly what I did here, right? So you send xy over here to something, but then when you drop that component, let's get back to xy. So this idea right here, we'll call that g. And it goes from R3 to R2. G would be considered a left inverse of this function, of the function f. That is because when we put g on the left in the composition, so g of f of xy, what happens? Well, you run x, well, let's see, f of xy is xyx, and then g, defined as dropping the last coordinate, would just be xy. Notice that it's the do-nothing function on R2, the domain, so it's the identity function on R2 is equal to this. So this tells us that g itself is a left inverse. Now, if we have a left inverse, then we know that the function is injective. What does injective mean? That means that there is no fiber that has more than one element in it. And if we have a left inverse, then we know it's injective. Let's see. How could that be true? Well, let's consider. Let's take any fiber at all. In fact, you look at the whole collection of codomain elements, right? Look at the whole collection of codomain elements over here. And, okay, so, and if you take a codomain element and you think of two different things being sent to it, think about what happens. Okay, via f. So f will go this way and g will take it right back to itself. But g is a well-defined function. It's not going to go take c to two different places. It only takes it to one, which forces these two guys to be the same, which forces the fiber over c to have only one element. So what we get is that if there is a left inverse, then the function will be injective. Thanks for watching.